My internship with Howard S. Wright of Balfour Beatty Company has been a great experience. I was hired as a BIM intern for the Portland, Oregon area. My work has consisted of a variety of things, and we will cover those throughout the video. I was located in the downtown Portland office, which gave me about a 40-minute commute to and from work. I was able to live where I grew up in Scappoose, which is a small town with a population of about 6,500 people. We will first look at a 4D schedule that I developed in Navisworks. It is called a 4D schedule because we use a 3D model and then allow the actual schedule to govern when things are in progress and then finished. We can see that parts of the model are green and then gray. The green portion of the model is when it is in progress, and then when the portion is finished, it will turn gray. This project is currently in progress and will house our new Portland office with a tentative finish date to be May of 2016. Next, we will get into the different proposals that I've worked on. All of these projects were modeled in Autodesk Revit and in SketchUp. We start with the expansion at the Valley Football Center for Oregon State University. We now are seeing the project called the Weiser Block that was in Lake Oswego. The next project was for our Special Projects Group, which handles our smaller projects in the area. This was for Nordstrom Rack. Last but not least, we see Hyatt House and the phasing plan that we used to demonstrate the different parts of the building that we are going to build. A job walk is always needed, so we will look at Hyatt House, one of our projects near the Portland waterfront. There are a few things going on in this job site. We have the forming of our pile caps going on. We were able to place our tower crane, and so the pump truck is giving us our concrete for our footing. Last, we have the excavating company digging their way around, creating areas for our grade beams to go in. An interesting fact about this job site is that on the last pile that they were placing, part of the pile driver broke. So the engineer gave us the go-ahead to drive that piece that was broken to the desired depth and then weld our rebar cage to that piece. Tekla Structures was first used for structural steel detailing, but over time they have developed the program into many different things. We are using this program to model our self-performed concrete. In this portion of the video, I am modeling the second-story metal deck where the concrete will be placed. With the different openings and slab edges, I had to clip pieces of the decking to match the actual slab. The next project I was working on is Jane Sanders Stadium at the University of Oregon. This model was given to us by the architect, and what I'm doing is going through the project and cleaning it up. We need to clean the model for two reasons. The first reason is so that we can use it as a background in Tekla so we can create our concrete model. The next reason is for our M&P coordination. This portion of the video I have imported the Jane Sanders Stadium into Tekla so we can start using it for our concrete modeling. Our problem is that the topography from the model came into Tekla as well, so I'm trying to get rid of it. You get out of school and think that your education stops, but it does not. You still further your education at work. This is a training we received for our new file sharing program. We are currently in the process of changing programs from BoxSync to Ignite. Many ask why change when the current application is working fine, and the answer is that it makes us more efficient at our jobs in the construction industry. Let's take another job walk. Remember the 4D schedule that you saw at the very beginning of the video? This job site is that 4D schedule. What you are currently seeing is the pouring of one of the decks. We see the PT cables, which are in red and kind of look like rebar. After the slab has adequate time to cure, the slab will be stressed with these cables, and the red you see is the sleeve to allow the cable to stretch. We take a little walk to the west and we can see the forming for the ramp that will be used for parking. There are 3 other decks below what you are seeing now, which is the lowest we have gone underground in the Portland area. We will get back to working and look at Navisworks. We use Navisworks for our M&P coordination and our clash detection. We can set up rules and standards to test for the different clashes. We are looking for any situation where the different models from our subcontractors clash together. We then create viewpoints to allow us to coordinate the new locations for the clashing parts. One of the very last projects I was on was a laser scan that we received for one of our projects. As you can see, this laser will scan in all directions and allows us to see the current building as it is. We can use this scan to help us understand what we are getting ourselves into, and also to allow us to create a model of the existing building, which would allow us to calculate how much demo we actually have to do. The uses for these scans are endless, and we are just touching the surface what we really could use this technology for.